Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to find the molecular formula from the empirical formula. So I'm going to do this by going through a problem in which we have to find the empirical formula first, and then from there we'll find the molecular formula. Now the key to going from the empirical formula to the molecular formula is comparing the molecular mass of the substance to the empirical formula mass of the substance. And so that's why whenever you're given a problem that is asking you to find the molecular formula, they have to give you the molecular mass of the substance. Without that, you can't get the molecular formula. And here's why. So let's take an example. So if I have, let's take glucose, for example. So glucose is C6H12O6. That is the molecular formula for glucose. These are the actual numbers of carbon, hydrogen, and oxygen atoms in a glucose molecule. If we compare that to the empirical formula for glucose, which is CH2O, you can see here that the empirical formula is 6 times smaller than that of the molecular formula. So you can see here that the empirical formula only has 1 carbon, where the actual formula has 6 carbons. The empirical formula only has 2 hydrogens. The molecular formula has 12. That's six times more compared to the empirical formula. And again, here we have 1 oxygen in the empirical formula and 6 oxygens in the molecular formula. Again, 6 times greater. So the number of atoms of each element that we have in the empirical formula is 6 times less than that in the molecular formula. So why is that important? What's the big deal there? Well, the same goes for the mass. So if I have 6 times the number of each atom of the elements in my molecular formula, then that means I have 6 times the mass amount, right? And we can show this empirically, right? We can say, okay, well, if I calculate the mass of this, right? If I calculate the mass of my glucose, it's going to be approximately 180. If I calculate the mass here, this is going to be about 30 grams. So this is about 30, right? So if I calculate this, right, so 30 times 6 gives me 180, right? Or, so that's 6 times, so this is 6 times smaller. And then what I can do is to get the factor that is the factor difference between these two, I can take the 180, the molecular mass, divide it by the formula mass of the empirical formula, and I'll get 6, a factor of 6. So that tells me that the difference between my molecular and my empirical formula is going to be a factor of 6. So I multiply the subscripts here by 6 to get the subscripts of my molecular formula. And that, in a nutshell, is how you're going to find the molecular formula. So let's go ahead and get into this problem. So we're given this problem. We're told that adipic acid is 49.31% carbon, 6.90% hydrogen, and 43.79% oxygen. And then they give us the molecular mass of adipic acid, and that's 146.144 grams per mole. Okay, so we need to find the empirical formula so that way we can calculate what the formula mass of the empirical formula is and compare that with the molecular mass of the formula of adipic acid. By comparing the empirical formula mass and the molecular mass, we can figure out what factor difference, by what factor do the empirical formula and the molecular formula differ, and then that factor is what we need to multiply by. Okay, so what we're going to do at first, again, if you're given percentages of the elements in your compound, you can just convert those to grams by assuming 100 grams of your compound, because percent is out of 100. So if I have 100 grams of my compound of adipic acid and 49.31% of that is carbon, well, 49.31% is 49.31 out of 100. If I have 100 grams, then that means 49.31 grams is carbon. So I take the 49.31% carbon, and that becomes 49.31 grams of carbon. And the 6.90% hydrogen becomes 6.90 grams of hydrogen, and the 43.79% oxygen becomes 43.79 grams of oxygen. Okay, so we have our grams. The next step is to convert the grams of the elements to moles, because we need a mole ratio. So we need this to be in moles. So we're going to take the 49.31 grams of carbon over 1, and we're going to multiply that by by the molar mass. So 12.011 grams of carbon on the bottom, 1 mole of carbon on top. So grams cancel out, and when I calculate that, I get, what do I get? I get 4.105. So it's going to be 4.105 moles of carbon. And then I do the same thing with my hydrogen. So I have 6.90 grams of hydrogen. And here I'm going to multiply by the conversion factor of its molar mass. So I'm going to put 1.008 grams of hydrogen on the bottom and 1 mole of hydrogen on top. So then I cancel out the grams. My calculator dropped on the floor, and I'm going to calculate the moles. And we get 6.845. 6.845 moles of hydrogen. And then lastly, I'm going to do the same thing with oxygen. So I have 43.79 grams of oxygen over 1 multiplied by its molar mass. So I'm going to have 15.9994 grams of oxygen on the bottom, 1.1 mole of oxygen on top. Grams cancels out, and I calculate the moles, And I get 2.737. So 2.737 moles of oxygen. Okay, so now I have the moles of oxygen. To get my empirical formula, I need to get the smallest whole number ratio. So I'm going to write a pseudo formula using these. Now, since, remember, the subscripts in your empirical formula are mole ratios. So what we can do is, one, we can use these three and find the smallest mole ratio by dividing by the smallest number. So the smallest number here is 2.737. So if I divide all three of these by 2.737 moles, then I'll get a ratio of 1 to something, right? So I'm going to write this in a kind of pseudo formula first. So taking these moles and writing them as subscripts in my formula. So I'm going to have C, carbon. So carbon would be 4.105. So that would be the subscript. And then for hydrogen, this is going to be the subscript for hydrogen. So 6.845. And then for oxygen, the subscript is going to be 2.737. Now, this looks weird, but remember, these are moles. And so I'm going to now reduce this by simplifying. So we want to divide by the smallest moles. So since 2.737 is the smallest, I'm going to divide all of them by 2.737. Divide this by 2.737 and divide this by 2.737. And when I do that, we get certain numbers. And when I do this calculation, so this 2.737 divided by 2.737, that's 1, of course. So that's going to be 1. I'll put a 1 there. 6.845 divided by 2.737. Oops. Sorry about that. So if I take 6.845, divide that by 2.737, then I get 2.5009. But that's really close to 2.5, so we'll just simplify that to 2.5. And then when I divide 4.105 by 2.737, I get carbon 1.4999. And again, that's really close to 1.5, so we'll just round that to 1.5. Okay, so much simpler numbers. We now have a ratio of 1 to some other numbers. So 1 to 2.5, 1 to 1.5. But we can't stop there because we don't like fractions. So we can't have subscripts as fractions. We don't use fractional subscripts. So we got to get rid of the fractions. So since we have a 0.5 here, we have to multiply by 2. Since we've got a 0.5 here, we got to multiply this by 2 and this by 2. But if we're going to multiply our subscripts by 2, we need to multiply all subscripts by 2 to keep the ratio. If we don't multiply this one by 2, then we don't keep the ratio. So if we multiply everything by 2, we end up with 1.5 times 2 is 3, so it's 6C3. And then 2.5 times 2 is 5, so H5. And then 1 times 2 is 2, so it's O2. And so this is the empirical formula. So empirical. So now that we have the empirical formula, now we can figure out what the molecular formula is. So here, remember, based on the example with glucose, C6H12O6, the molecular formula is 6 times larger than the empirical formula for glucose. Remember, the empirical formula is CH2O. The molecular formula, C6H12O6. So you have 6 times the number of each of those atoms, carbon, hydrogen, and oxygen, in your substance. So if that's the case, then we would expect that the ratio of the masses would be a factor of 6, would differ by a factor of 6. So all we need to do now is find the ratio of the masses, comparing the empirical formula mass to the molecular mass that we were given. So let's calculate the empirical formula mass. So if we calculate this, we'll add together 3 carbons, the mass of 3 carbons, the mass of 5 hydrogens, and the mass of 2 oxygens. And when we do that, we get 73.072 grams per mole. So this is the formula mass or molar mass of the empirical formula. So if we compare this with this, we can find the factor. So this is the molecular mass. So molecular mass over empirical formula mass. If we divide one by the other, then we should get a factor that tells us the difference, the factor by which the formulas differ, because the formulas differ by the same factor as the masses differ. So we take the molecular mass, 146. So 146.144. And we're going to divide that by the empirical formula mass. That's 73.072. And you can already see it's about a factor of 2. So if we divide this, so 146.144 is basically equal to 2. So that's the factor by which the empirical formula of adipic acid and the molecular formula of adipic acid differ. So since we know that the empirical formula is C3H5O2, we now know that in order to get the molecular formula, we multiply the subscripts by the factor of 2. So then the molecular formula becomes C, so 3 times 2 is 6, so that's C6. 5 times 2 is 10, so that's H10. And 2 times 2 is 4, so that's O4. And that, ladies and gentlemen, is the molecular formula for adipic acid. And so again, this is a great example of how you can find the molecular formula from the empirical formula. So I hope this was helpful. If you enjoyed this video, if you learned from this video, then please, by all means, like the video, share the video, hit that like button somewhere, I think over there or over here. I don't know. Find it, click on it. Also, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos that I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, or if you have a problem or a question you really need help with and you want me to go over it for you, please put it down in the comment section. I would love to do that for you. Thanks for joining me and have a great day.